Hello and welcome to our last video on how to use R in this course. Today we'll be talking about correlation and regression in R, and I have my R console up. I have my examples in R dataset already loaded in, and those variables already stored into their own objects. This should be old hat for you by now. I also have opened up here correlation and regression in R text document, which will have some of the code that I'll be using. And so usually when we're looking at correlation and regression, the first thing we're going to want to do is look at a scatter plot between these two variables. So I could do that with the plot function. And let's just say we're going to analyze height and weight. So when I do that, I get my scatter plot. It doesn't look to be have any sort of linear pattern. So regression and correlation probably isn't going to be the best analysis to use. However, just for example's sake, we'll go ahead and run with it. So correlation, we can do a couple different things here. One is just to find the sample correlation by using the core function. And since it doesn't really matter which variable is your x variable and which variable is your y variable in correlation, go ahead and do it however you want. I usually do it in the order in which I would use those two variables anyway. So if I'm going to try to use height to predict weight, height's going to be my x, it'll go first, weight will be my y, it will go second. For correlation, it doesn't matter. For regression, it will. So just the core function, if I hit return here, and we see we have a very low correlation value, practically zero. Now, do we know how significant that correlation value is statistically? Not by just using the core function. However, we can use the core.test function, and we'll do height, weight, and I'm going to include this alternative here, although I don't really need to. R is going to run two-sided tests by default. And that's usually the way you see correlation tests run. We're just trying to show that it's different from zero. You don't even have an option of putting in a different correlation value. It's always going to test whether or not a correlation is greater than, less than, or not equal to zero. If I hit enter here, we're going to see the exact same sample correlation we calculated with the core function here. I'm given a confidence interval for my correlation and my p-value. And here you can see the alternative, true correlation not equal to zero. That's what we're going to usually be testing. So pretty simple line of code, core.test, x variable, y variable. If you want to change your alternative to a greater than or less than, you can include it. Otherwise, you can just leave it out and run the core.test function with just your x and y. It'll give you the same output. So that's correlation. Regression is going to be another pretty similar thing. We're going to build a model, a linear model again, like we did with the ANOVA function. This time we're going to use the LM, or linear model function, and we're going to put our dependent variable first, which is weight in this instance, and our independent variable next, height. So I'm trying to use height to predict weight. You can obviously do it the other way if that's what you're interested in. Just for this instance, I'm going to be interested in using height to predict weight. And so height will be independent, weight dependent. Hit enter here, and now summary of that fit, and it's going to give me all the things I need to know. So, and most things that I don't need to know. Like these residuals, we're not going to worry too much about them. We're going to focus in here on this coefficients table. So in this estimate column, here's where I'm going to get my slope and my intercept value. So if we're going to write out this model, I'm going to say that y hat is equal to 213.51, my intercept, as you can see here where it says intercept. And then I'm going to subtract off my slope value, 0.256, times x, where x is going to represent height. So it's really easy to get yourself turned around. Maybe put your independent variable where your dependent variable should be, and vice versa. Always make sure that your independent variable, whatever it's called, is right next to your slope estimate. If that's the case, then you know you've got the right model. If your dependent variable is next to your slope estimate, you've flipped them. So go ahead and just hit the up button and change that around. A couple other things we get out of this output. Here's our p-value to test to see that the slope is not equal to 0. So this is going to be beta sub 1 not equal to 0 in the alternative hypothesis. That's the p-value you're going to get for that. That's going to be what we'll be interested in. Rarely are we ever interested in tests for the intercept. Also, in here, you're going to get this multiple r-squared value. That's going to be the r-squared that we've been talking about. So r-squared in this case is 0.02379%. Not very good. We'll skip the adjusted r-squared. That's going to take a few other statistical things into account. Going to be out of the scope of this class. So always focus on this multiple r-squared. So very small percentage of the variation in our weight is being accounted for by our regression equation here. So that's correlation and regression in R. Pretty quick video. So if you have any other questions or you run into any problems with your code, send me an email and we'll get that fixed right up for you. Hopefully you've found these videos helpful throughout the semester. If you have any recommendations of things I can be doing to better serve your needs, please do let me know that. And hopefully you've had a good time. I know I have, so take care. Good luck on wrapping up this semester strong, and see you later.